Welcome to the first topic of Module 7, Fingerprints. We will begin by discussing the three major fingerprint patterns and their subclasses. We will also discuss the various ways to collect and develop latent prints and the two main methods that are used for fingerprint classification. Finally, we will discuss the APHIS system, which is currently used in most law enforcement agencies and also forensic laboratories. If we discuss specifically what is a fingerprint is a reproduction of the friction ridges which are found on the palm side of fingers and of the thumb. During the development of the fetus, the basal layer grows more quickly than the epidermis layer, causing folds and buckles in various directions. This is what creates the complex pattern of fingerprint ridges. If we talk a little bit about the history behind fingerprint use, the first practical use of fingerprints was in 1858 by William Herschel, who used fingerprints to prevent forgery on legal documents concerning illiterate Indians. In approximately 1880, Henry Fald claimed that fingerprints did not change over time and they could actually be used for a classification system for identification. So around 1892, Francis Galton developed a classification system that was based on loops, arches, and whorls. Sir Edward Henry also developed a classification system. However, this was developed on a numerical basis and was used primarily in England. Several other countries have also developed classification systems or are using either the Galton or the Henry system at this time. However, around 1903, the use of fingerprints became a lot more prevalent for identification uses, and this was because the current method that was being used for identification had proven unreliable. This occurred, as we discussed previously, when a second prisoner was brought into Leavenworth Federal Prison, and his dimensions, according to the Alphonse Bertillon's system, were exactly the same as a prisoner that was already in the system. So they had two individuals that, according to the current identification system of measurements, had the exact same measurements or identification. So at that point in time, fingerprints became the identifying characteristic that was going to be used in the future. At that time, the Galton system was being used by law enforcement. Today, it's more currently a version of the Henry classification system. Fingerprints may be impressed in a material, left as a visual print, or left on items as a latent print. And this is because of the pores on the friction ridges are going to emit perspiration, which allows that latent print to be left on an item and then be visualized through either powders or chemical enhancers. We think about fingerprints following three fundamental principles, and this is what allows their use in criminal investigations. First, that a fingerprint is an individual characteristic, that there are no two people that have been found to have the exact same fingerprint pattern. This even includes identical twins. Second, that a fingerprint pattern will remain unchanged for life for that individual. It might have slight changes due to scars and skin diseases. Finally, that fingerprint has general characteristic ridge patterns that allow it to be systematically identified. So if we talk about this identification, we classify fingerprints into three main patterns. Whether it is a loop pattern, which entails approximately 65% of the world's population, a whorl pattern, which is 30%, or an arch pattern, which is approximately 5%. To identify the fingerprint patterns as either loops, whorls, or arches, cores and deltas are used. A core is the approximate center of a print. A delta is a point on a ridge where divergence occurs. A loop is a ridge pattern that is characterized by lines that enter on one side and recurve, touch or pass an imaginary line drawn from the delta to the core, and then terminate toward the same side of the print. You can see from this slide that loops can be classified into two subclasses, either radial or ulnar. Radial loops are formed toward the right. Ulnar loops are formed toward the left. We can also classify fingerprints into a whorl pattern. Whorls are ridge patterns that are generally rounded in shape and have at least two deltas. These can also be subdivided into either plain whorls, central pocket loop whorls, double loop whorls, or accidental whorls. The final main pattern is arches, and these are ridge patterns that are characterized by lines that enter the print from one side and exit from the other. This can also be subdivided into plain arches or tinted arches, where there's more of a upthrust in the center of that arch itself. Once that main general ridge pattern has been determined, the analyst is going to look for various minutiae features that may also be present within that fingerprint. It is these various characteristics that make that fingerprint unique. So once that main category pattern has been determined, if it is an arch, a loop, or a whorl, then they're going to identify as many as possible of the different minutiae in that fingerprint itself. So now that we know a little bit about the various patterns and the minutiae that can be found in fingerprints, we need to be able to detect those fingerprints. And once again, there are going to be some fingerprints that are going to be visible. These might be things such as someone who has an extremely oily or greasy hand that actually touches paper. But in most instances, it's going to be where a latent print has been left, and it will be necessary to develop that print, either through the use of powders or chemicals. Generally, powders are going to be used on a smooth surface, and chemicals are going to be used on a soft or a porous surface. There are several different powders that can be used, and these are going to be chosen according to the actual surface itself. So if someone is working and trying to develop latent prints off of a white or a light colored surface, they might choose to use black powder or a carbon or charcoal based powder. However, if the item itself is extremely dark colored, they might choose to use a gray powder or an aluminum-based powder so that that latent print will be a lot more visible and able to be lifted from the item itself. So if we talk about lifting that actual item, after the print has been dusted, it's going to be visual, and first of all, it should be photographed. Then we can lift that print using a hinge lifter that includes a adhesive sheet which is attached to a backing sheet. Opening up the hinge lifter exposes the adhesive and allows it to be pressed against the dusted latent print. So the dusting or the powder will adhere to the adhesive, allowing it to be lifted, and then the lifter is closed, putting the adhesive onto that backing sheet, which is going to then protect that lifted latent print. Several chemicals can also be used to assist in visualizing latent prints. The first of these is iodine fuming. To perform iodine fuming, the item itself must be put into some type of a tank or a closed container. And then the item is going to be exposed to iodine crystals, which cause the latent prints to become visible. These prints will disappear or fade with time, so these must be photographed for comparison. Ninhydrin is used primarily in a lot of laboratories. This is a solution that's going to react with the amino acids in the prints, and they will be developed in approximately an hour or two. This can be accelerated if the actual object is heated. In some instances, it might be preferred to use silver nitrate, and this is going to react with the chloride in the lipids and oils and fats of a print. So the silver chloride will then turn the prints to a gray color when exposed to light. In a lot of instances, superglue is now used to develop latent prints, and this must either once again be done in a closed container or with a fuming wad. The fumes of the superglue are going to bind with the proteins in the prints, which form a white visible print. There is also small particle reagents that can be used. These are going to be primarily used on wet surfaces. They can come in two different colors, so you can choose if you're working with a light colored surface or a dark colored surface. But the small particles are actually suspended in a solution that's going to attach to the fatty substances in the print. And then also there is one chemical enhancer that has to be used or visualized with an alternate light source. This is DFO, and it also combines with the amino acids in the prints when heated. But once again, this has to be visualized by using an alternate light source and then viewing it at various wavelengths. So once we obtain our latent prints, they can be classified and then compared to known print cards or scans. Officers can obtain known print cards by applying the pads of the fingers or the thumb to an ink pad and then slowly rolling them onto the fingerprint cards. They want to make sure that they always collect all 10 fingers, since the fingerprint patterns and the minutiae can vary from finger to finger. This can also be done through the use of a computer program which develops a live scan of that fingerprint. Classification can either be done manually or automated. If we think about the manual classification, it is a primary classification system, which is a numerical value on. This is done by inserting values into a formula according to the pattern
that's present on each finger. If an arch or a loop is present, a 0 is given. If a whorl is present, the value for that particular finger is inserted into the formula. So if we look at a particular example, if this individual had arches and loops on the right ring and right little finger and whorls on the rest of the fingers, this is the numerical identification that would be obtained. In most instances, the automated fingerprint identification system, or AFIS, is used. This is a computerized system that classifies fingerprints based on points where ridge lines end or where one ridge splits into two. The position and orientation of the minutiae are stored in a geometric pattern. Fingerprint hits, whether it is through the fingerprint card or through the AFIS system, are always going to be verified by an analyst. So they're going to actually look at that specific latent print and the known print in more detail before any identification is actually reported. This concludes our discussion on fingerprints.